Hi everyone, in this video, I would like to discuss this problem from Leetcode 223 rectangle area. This is the agenda for this video. So first, I'm going to discuss the problem statement and then dive into concept terminology. After that, I will walk through the algorithm step by step, and then I will implement the algorithm in both Java and JavaScript. Finally, I will discuss the time and space complexity. So let's have a look at the problem first. Given the coordinates of two rectilinear rectangles in a 2D plane, return the total area covered by the two rectangles. The first rectangle is defined by its bottom left corner. It's here, ax1, ay1, and its top right corner, ax2, ay2. So that is the first rectangle. Let's have a look at the second rectangle. The second rectangle is defined by its bottom left corner, which is here, bx1, by1, and its top right corner, bx2, by2. So the input for this problem is all the coordinates, and output is 45 for this example 1. So how do we get 45? Let's have a look. So from here, from the visual observation, we can see that rectangle 1 highlighted in here, the area from visual observation, we can see that it is 24. For the rectangle 2, which is this one, the area of this rectangle is 27. And the overlap area which is this one, highlighted in blue color. So how do we get the area? The total area is 27 plus 24, we get 51. From here, we have to subtract the overlap area because it is overlapped twice. So we have to subtract the 6 and then we get the final area 45. So this is from the visual observation. And let's have a look at the example 2. In the example 2, all the coordinates given. So for the rectangle 1, which is in purple color, the coordinates are like this. And then we also have a rectangle 2, the rectangle coordinate are like this. So bx1 is -2, by2 is -2, and so on. So from here, you can see that this rectangle, purple rectangle, rectangle 1 and rectangle 2, their overlap is complete. They are on top of each other. So therefore, the area is 16. Let's have a look at example 3. Even though example 3 is not given, we have to consider for this edge case. So there will be a case that the area 1 and area 2 can be anywhere on the coordinate system. However, the rectangle 1 and rectangle 2, there will not be any overlap whatsoever between these two rectangles. So that is the case, example 3. So now I want to introduce you to the concept. The first one is the rectilinear. So rectilinear, linear means straight line. So rectilinear may move in a straight line. The second one is the rectangle property. Rectangle property, opposite sides are parallel and they have the same length. That is the area. We can calculate the area of the rectangle by multiplying the length and width of the rectangle. The fourth is just the terminology, which is coordinates. So coordinates of this rectangle are given in this formula, like so. ax1, ay1, and ax2, ay2. So now we have all of the concept clear, then we can have a look at the algorithm, how we can solve this problem. So these are the steps. So I'm going to use the example 1 as an example, visual example to walk through this problem. So first, we have to calculate the area, rectangle 1 area. So we can call it area 1. Second step, we can calculate the rectangle 2 area. We call it area 2. In the third step, we have to calculate the overlap area if there is any. From the example, we have seen that there could be a case that there won't be any overlap whatsoever. So in here, we have to consider for all of these three cases. In step 4, we will get the total area. The total area will be area 1 plus area 2, rectangle area 1, rectangle area 2. We will add them up, and then from there, we will subtract overlap area. So let's have a look at the step 1 and step 2. So we know that the rectangle area is length and width. We multiply these two, and then we will get the area. So from here, we are given the coordinates of each rectangle, ax1, ay1, ax2, ay2. So to get the length of this purple rectangle, well, how we can get the length? We can get it by ax2, which is here the same on the x coordinate, minus ax1. So if we do that, we will get the length. For the width, we can do the same thing, ay2, which is here, and the ay1, which is on this y coordinate. So if we subtract these two, we will get the y coordinate. So that is for the area 1, which is for the rectangle 1. So we can do exactly the same thing, use the same concept for the area 2. So I will not go that in detail. So now we have calculated for both area 1 and area 2. So I will take you back to the algorithm. So we have done step 1 and step 2. So let's do the step 3. Step 3 is a bit more involved. So before I go into step 3, first I want to bring up this tree diagram to remind you there are 3 cases that we have to consider. The first example, which is the one that I'm currently using, partial overlap. Example 2 is total overlap. Example 3, there is no overlap. So when we think for the overlap area, we have to cover, our algorithm should cover all 3 cases. So first, let's have a look at for the example 1. For the example 1, I have marked in the blue color. So we need to know the left side of this overlap area, and also we need to know the right side of this overlap area. What can we do with that? If we get that, then we know from the formula of the rectangle is length times width. From here, what we can get is right minus left. From here, if we do that, then we will get the length. So how can we calculate left and right? Let's have a look. So for the left, we have to compare the 2 values from each rectangle. So corresponding rectangle. So for bx1, which is here, bx1 and ax1. So we are simply comparing the left border of each rectangle. And then for the left side, to get the left side, we have to get the maximum value. So we will compare these 2 values and we will select the max. If we don't select max, then we will end up with the incorrect area. Therefore, we need to select max. For the right, again, we are comparing the right border of each rectangle. So in here, we are going to compare bx2 and ax2. And in here, we can see that we need to select the minimum value to get the correct border for the overlap. So now we have got left and right. So what we can do to get the length of this rectangle, we simply subtract right minus left. From here, we will get the length. So how about have a look at the width? For the width, we need to know the top border and the bottom border of the overlap. So for that one, we have to do exactly the same thing like we have done for the length, but in here, the values that we have to compare is of course different. To get the top value, we have to compare ay2 and by2, and from here we can see that from visual representation we can see that we need to select the minimum value. Same thing for the bottom, we have to compare 2 values, ay, which is here ay1 and by1, and from here we can see that we need to select the maximum value. And to get the width, we simply subtract these 2 and then we will get the width. Now we have calculated both length and width, So we can simply calculate the overlap area. So to calculate the overlap area, these conditions must be satisfied. Top have to be greater than bottom, and right have to be greater than left. So now I have discussed all of this algorithm concept. So let's go into Java code. So this is the function signature. First, as a first step, we have to calculate the area for each rectangle, which is these two lines of code. In area 1, we are calculating the rectangle 1 area. Area B, we are calculating the area of the rectangle B. So I will just go through for the area A, which is AX2, AX1, AX2 minus AX1, we will get the length. AY2 minus AY1, we will get the width. Okay, so now after calculating these two areas, we will first the next step is calculate the overlap. To get the overlap area, we need to get the length and the width. To get that, so this step we are calculating for the length. To get the length, we have to compare the two value of the left border, and to get the left, we have to select the maximum value. For the right, we need to compare the two value of the right border, and then we have to select the minimum value. So now we have calculated the length. The next step is going to be calculate the width. So for the width, we need to calculate top and bottom. So for the top and bottom, again, we have to compare the two value. For the top, we have to select the minimum. For the bottom, we have to select the maximum. So now that we have to calculate these two, length and width, the next step is quite easy. First, we have to check for first we will initialize the overlap. Area initialize as 0, and these two conditions must be satisfied. Right have to be greater than left, top have to be greater than bottom. And then we will calculate the overlap area. And then the rest is, after that, we have calculated all of that, and we can simply return area 1 plus area A plus area B. From here, we need to subtract overlap. From that way, we will calculate the correct area. So next is the time and space complexity. So time complexity, time is constant. We are simply assessing all the coordinates that are given. So for that, the time complexity is constant. Space complexity is also constant because the only thing that I have used is the variables. There is no additional data structure is used. So therefore, space complexity is also constant. This is the JavaScript code. It's exactly the same. The concept is exactly the same. The only difference is this part, because in JavaScript there is no Math.min or Math.max, that math module, so I have to use a ternary operator. Everything else is the same. Thanks for watching.